Assalamualaikum and good afternoon. My name is Mazidah Binti Mohammad Abid and I will be presenting about how to obtain the IV characteristic of diode and do the graphical analysis based on IV characteristic figure 1. To obtain the IV characteristic of diode of figure 1, we make a value table of VD and ID. First, we use standard VD value for the table and shortcut equation to find ID. We use IS equal to 20 nanoampere, eta equal to 2 for silicon and Vt equal to 26 mV. After that, we plot the IV graph on the graph paper. For the need value, we got 0.7 volt. Then, we do the graphical analysis to make the load line on the graph we obtain. To do that, we use Vd equal to 0 volt to find ID, and to find Vd, we use ID equal to 0 milliampere. So we got the value of Vd and ID, and after that, we make the load line to find Q point of the graph. We got VDQ is equal to 0.6 volt and IDQ equal to 4.4 milliampere.
Assalamualaikum and hi, my name is Aisyah Mariyah Binti as Jamros and I'm going to present on the stimulation for question 1. So firstly, we are going to look at the stimulation for the forward bias. For this circuit, we use 5 volt for the V1, 1 k ohm for R1 and diode we use 1N4001G model. So by using the IV analyzer, we got this kind of graph. From this graph, we can find that the knee voltage is 597.0 mV. Next, by using the same circuit, we are going to look at the stimulation for the reverse bias. By using the IV analyzer, we will get this kind of graph. This graph is in the negative state, which is different from the forward bias. From this graph, we can see that the breakdown current is negative 9.191 milliampere. And that's all from me. Thank you.
Greetings, I am Rayner and let's get through this manual calculation for figure number 2. Before going further into the calculation, it's better to analyze this circuit to find suitable circuit analysis to be performed. I will apply Thevenin method in this circuit analysis. So this is how the circuit will look like where the DC source is short circuit and the diode was opened. Simple calculation was made to find the Thevenin resistance and Thevenin voltage using the voltage divider method. From these values obtained, this is how the Thevenin circuit will look like. Onwards, we could apply KVL in order to find the maximum diode current and maximum diode voltage, where at maximum diode current, the voltage will be at 0 and vice versa. When these values were plotted, it will result in what we called a load line. Now we are closer to the end. The only remaining thing we need to do here is to plot the load line on the same graph as the IV characteristic curve of diode to find the operating point. By the way, we just perform a graphical analysis here.
Assalamualaikum and hi everyone. My name is Sofiya Binti Mohammad Hashim. I will explain about the simulation question number 2. For the simulation question 2, we are using multisim. First, we just recreate the circuit in multisim to simulate the circuit. We just add the voltage source which have a voltage of 20 volt, resistor 1 with a resistance of 500 ohm, resistor 2 with a resistance of 100 ohm, resistor 3 with a resistance of 100 ohm, and diode IN4001G which is a silicon diode. Then we simply link it with a wire. To simulate the circuit, we connect the diode with the IV analyzer and then we run it. Lastly, we analyze the circuit and record it to be compared with the result obtained from the graphical method.
Hello, my name is Mohammad Haziq and today I would like to discuss our answers for question 1 and question 2. For question 1, we have 0.6 voltage for the manual calculation of the diode voltage, while for the simulation of the diode voltage we have 0.59, so it's not really much of a difference. Manual calculation of the diode voltage we have 0.7 volts, while for the simulation of the diode voltage we have 0.7 volt as well, so it's the same. So why is there dissimilarity between the two methods? Well, this is because there is a lot of factors that could affect the answers for the simulation or the manual calculation. So the factors that could affect their answers are heat loss, interaction between components, and also modeling assumptions.